Welcome back, Mr. Brown, with you again. So we are on the last aspect of functions, which is dealing with composite functions. Now, composite functions means to combine at least two other functions. So now here in this particular question, you get f of x equals 3x plus 4, g of x equals 2x plus 1, h of x equals x plus 1. Now if you realize that I have f, g, h, for functions you can have any letter representing, so it can be a of x, b of x, m of x. That the letter is irrelevant. It's just that you need to focus on what the function itself is. Now for this particular function, it says f of g of x. When you see a function that is a composite function, it simply means that whatever functions comes second, you should place it in the first function, or the function that comes right before it. So in this case, f of x is the original function that we'll be placing g of x into. Now f of x is equal to 3x plus 4. So it means that where you see x in the f of x function, you'll replace it with the entire function for what g of x is. So in this particular case, g of x is equal to 2x plus 1. So it means you'll write back this 3 because it's a part of f of x function. So that's 3. Replace your x with the entire g of x function, which is 2x plus 1. Close bracket. Put back your plus 4, which is a part of the original f of x function. When you get here, you'll do the distributive property. So what's on the inside multiplied by the outside. So it will be 3 times 2 of x, which would give you 6x. And then it's 3 times 1, which would give you 3. And then you bring down what's on the outside. So plus 4. Now if you realize that this has an x, this does not have an x, this does not have an x. So it simply means that the two without the x's are similar terms or like terms, so they can be added or subtracted from each other. In this case, it's 2 plus signs, so it means that they should be added together. So it will be 6x and 3 plus 4, that would give you 7. Now, if it's a case where it's 1 is a minus and 1 is a plus, different signs means you would subtract each other. And if it was 2 subtraction signs, you would add the numbers together and keep the minus sign before it. Now, what would you do if you get a composite inverse? So it simply means you will have to compose both functions and then find the inverse of it. So this is g of x into h of x. So the original h of x function is x plus 1. So it means replace the entire x with what the g of x function is, which is 2x plus 1. So it would be replacing this x, so that's 2x plus 1 plus 1, which was in the original function. Now 2x plus 1, both of these does not have an x, so you can add them together. So that's 2x plus 2. So that would be the composite function of h of g of x. But now it requires you to find the inverse. Now to find the inverse, you will have to replace this and write the letter y. So it will be y is equal to all of this, which is 2x plus 2. Just like with normal inverse, you'll switch them around. So x is equal to 2y plus 2. When you get here, you'll start trying to solve to get y by itself by undoing all operations. So it's 2 was being added to y, so you'll do the opposite, which is subtract. So you'll say x minus 2 equals to 2y. Here, the y is being multiplied by 2, so you do the opposite, which is to divide. So this would be x minus 2 all divided by 2 is equal to y. And that is all you do for composite inverse. So it doesn't really matter how the functions look. If you know how to evaluate a normal function, find the composite of a function, or just to do the inverse of a function. When they merge, the process is just to complete one of each step at a time, and then you'll get the final answer. And if I had replaced this x with a number, it simply means that when you get here, you'll just take out the x and put in the number and find the final answer for it. So I hope this video would have helped you with understanding how to find or calculate composite function and how to find the inverse of composite functions. So thanks for watching and tune in again with Mr. Brown while I explain other mathematical concepts.